Thank you all. Good morning, good afternoon, and good evening, wherever you are. This is Ravi. I lead the big data and analytics practice at InnerMinds. I would quickly introduce the InnerMinds and what we do, and it'll be about a few minutes, and then we would then get to the topic on hand, which is how AI can help in risk and compliance and how it can drive risk and compliance. We do want to make this an interactive session, so therefore we have broken this 1 hour of time that we have into three parts. We will have about 20 minutes going through risk and compliance and what aspects of it can be governed by artificial intelligence. And we will talk through some of the use cases there, and how AI will make a difference, and how risk and compliance has been done historically, and where it could probably lead to some problems and how AI can overcome that problem. And we will have about 20 minutes going through some of our prior work that we have done, and particularly in the context of unstructured data and how AI can help piece the things together from unstructured data, whether it is text, audio, video, images, etc. And then we would have about 20 minutes for Q&A, to let the audience here ask questions, and then try and answer those questions and making it interactive thereof. So at any point, if you have a question, please use the questions menu available here in the GoToWebinar. You can also do things like raising a hand, etc. We will be able to notice those and respond in time, or we can actually also put all these questions together at the end, and go over those questions, and get the discussion there. So a quick overview about InnerMinds. InnerMinds is a digital solutions company based out of San Jose in the US, in the heart of the Silicon Valley, and it has offices, in the rest of the cities in US, such as New York, Texas, etc., and also offices in Europe, in Switzerland, and London, and again delivery centers in India. So we do digital solutions, and using particularly the cutting edge technologies such as AI, blockchain, Internet of Things, security and cybersecurity, and also the modernization of legacy systems into digital systems, with mobility as one of the primary ways in we go digital. So that's a brief about InnerMinds. We have delivered AI solutions in the last 6 to 7 years. We used to call it machine learning and data science before, and in the last 2 years we moved to AI. And there is a difference between machine learning and AI that we think is real, and we therefore work on AI from the point of view of automation, and that's what we will be talking about, automation of risk and compliance in today's discussion. So on the risk and compliance point of view, and if you look at the GRC, right, and the governance, risk and compliance in totality, and look at all aspects of it, starting with having a strategy of what would be the governance of a particular corporate, and what are the things that it does, and what is it responsible for, not just from the point of view of, say, a law or a regulation, but responsible from the point of view of, say, a social, or even from a sustenance and also sustainability point of view. So there is the strategy first, which goes then to define a set of policies and standards that the business wants to adhere to, and achieve by the way of, say, compliance. And then there is obviously the tools to ensure that those policies and standards are adhered to. starting with an information security architecture that helps in achieving those standards, and then obviously in effecting those policies, and also towards training and making all stakeholders, not necessarily only employees, but also everybody in the ecosystem, including partners, vendors, contractors, etc., uh, being sensitive to these policies and standards. And then ensuring that you are also then achieving a certain level of certification or accreditation and reporting, that you're compliant to those standards that you have sought for the business. So this is all the thinking part of and the strategizing part of risk and compliance. And what you see on the right and the colored hexagons is the operational part of the risk and compliance, in terms of one, having a framework that defines risk quantitatively and measures up the events that are happening with respect to a business, and then alerts for any heightened or any threat, and then therefore allows for some remedial actions to be taken. So a risk framework and a quantitative approach to risk, and defining a threat assessment, and then having a response system as part of this risk management framework. And and a subset of that, and I just mentioned this, that a threat and vulnerability management is hard to any risk management framework. And you would see that threats either detected automatically or as reported by humans and various stakeholders, including whistleblowers, and then having an effective mechanism to then investigate those threats and then remedy those threats. And you also have incident management, which is more at a raw incident level, not necessarily forming into a threat, and the ability to then have these incidents monitored, and then map to a certain level of risk, and then therefore a certain threat, is also an integral part of the operationalization of risk and compliance. And then of course you have the overall compliance to then report what's happening with respect to a business and business operations towards a policy and standard, and then highlighting those things that are complied with and alerting on those things that are non-compliances. You also have forensics to go then and go and investigate on a breach that might have occurred, or a non-compliance or a non-adherence that might have occurred, and to trace back and to see what happened and why it has happened, and how it can be fixed from a point of view of, say, a process, or a person or a technology. So these are the operational aspects of risk and compliance, and this is where we think that AI can play a big role. And what I believe, and therefore you will see that very soon in a case study that we will discuss, is that you cannot rely on humans alone for achieving this risk and compliance and for operationalizing the risk and compliance, for two reasons. That one, humans will make mistakes and tend to overlook on things, etc., and then you will therefore need a system and an automation system to supplement that human intelligence and the human monitoring and oversight with the right facts, so that these mistakes are avoided, and right opinions with so that the mistakes are avoided. And secondly, humans are also complicit to several breaches of risk and compliance, and we have numerous examples of that, and we will discuss a couple of them very shortly. So you cannot have a system that will rely only on humans, and that's where we think that AI will play a big part in terms of the operationalizing of the risk and compliance. So, from the point of view of some of the areas that we mentioned where AI can help, the hexagons here. If you look at the four key aspects of incident management, where you are having a system where either through, say, some humans who are reporting the incidents, or through, say, some bots or some kind of probes that are actually looking at all of the business operations and reporting some incidents, and then you having some monitoring or an oversight mechanism to see these incidents and triage these incidents and classify these incidents based on severity, and then escalating these incidents for say human review. So this is where we think that AI can play a big part as businesses expand, as things go digital, and then as businesses are now responsible for not just within their organizational boundary but everywhere. It is important that a proper incident management system backed by automation is set in place, so that the scale is better managed. And uh, and we believe that AI is inevitable and a must have in order to set this incident management on automation. Similarly, on the threat and the vulnerability management, having these incidents mapped to a threat and threat to the business, from various points of view, and then again classifying these threats as various levels of severity, and having a response mechanism and a remediation mechanism for threats is also something that has to be driven on automation, simply for the reason that the scale of threats and the scale of the incidents that map to a threat is way too high for any set of humans to manage. And and finally, on the compliance side, we are dealing with data in various forms and shapes, and particularly in unstructured data is no longer lying in terms of say known schemas, known structures, known types, etc. Within the business boundaries. Data is lying everywhere in the form of the data of your customers, and the partners that you are trusting, and the data that is put by your customers in your partners ecosystems and so on, and you are ultimately responsible for that as well. And therefore managing all of this unstructured data and ensuring that you're able to understand the data and the risks thereof, and are able to translate it to back to your policy and back to your standards is also important. And this is an area that AI can help as well. So I think this is best explained in the form of an example, a case study. And I think a week prior to this webinar, we had a different case study, and it was very contextual, and it was at the right time. And we were worrying whether that would be in the top of the mind of people. And then the good and the bad. The bad thing is that these incidents are happening at such rapid pace that we have an example or a case study almost every day. And the bad and the good thing is actually that therefore then this is the time to act decisively on risk and compliance, and this is the time to set in processes and systems, and particularly drive automation for risk and compliance, so that we now have the right mechanisms, humans, and supplemented by AIs and bots that will drive this risk and compliance. So I want to take an example here, the Cambridge Analytica. Not sure if many of you are familiar. This is real live as we speak, and it's something that's just reported a week back, and it's one of the biggest corporate scandals affecting Facebook, and caused substantial drop in the share price of Facebook, and loss of its market capitalization. And a brief context on what exactly happened, that Facebook has the data access APIs to several partners of its, who build apps and other solutions on the back of Facebook user data. And what happened was that there is this company called Cambridge Analytica, which is one of such partners of Facebook, which accesses data from Facebook of the Facebook users. And it was reported in the press that Cambridge Analytica took private user data in violation of Facebook's data access policies, and use that for both commercial and political purposes. So one of the things that is being talked about is that this data was used in the Trump campaign, and Cambridge Analytica was one of the solutions that Trump and his campaign team used to drive user engagement and also obviously rally for their campaign. So if you, I would not go too much into what exactly happened, but just briefly tell us to what caused the scandal, how it could have been avoided, and how AI could have helped. So what caused the scandal very clearly is excessive data accesses that Facebook allowed to its partners and APIs. And I remember that somewhere around 2012, you could get access to every user activity on Facebook. Of course, there is a consent, and there are terms and conditions whenever you basically open an app. But that's all too much in the fine print, and very few people have the ability to understand and therefore assess from a risk point of view what it entails. And since the app provides some function, and of course there is a lot of marketing and promotions around that, we tend to get trapped into those apps. So but still, as Facebook, you would expect Facebook to do those checks and put in those checks that the private data is not going into those apps, and as well that there would be adequate protection and measures to ensure that the users are not excessively sharing that data. So what Facebook lacked was to have that kind of control system on what data is being accessed, how much of it, right, and how much of the data is being actually used, and for what purposes is it being used. So Facebook on paper has a set of terms and conditions for the developers and for the app creators, but they hardly check, and they have never checked, and that's one of the reasons why this scandal has happened essentially. And also the also it is accused at least that Facebook knew that there were these apps that were taking away excess data, and obviously their developers, their engineers, as well as their sales knew the level of access of the data, and where the data was being used, but they probably chose not to act, right? And how this could have been avoided, clearly it is about defining the right policies. Facebook lacked the proper policy on data access and where it could be used, or it was too high level, or it was too vague or abstract, allowing the app developers to escape through some fine print. And that was one way in which this was exposed, that the act lacked adequate protection. And secondly, they lacked the monitoring mechanism to see what exactly was happening with these apps, and what data was being used by these apps, and how they could have actually sensed this. And lastly, they never audited some of their processes, and they never audited whether what they stated as their systems and their risk and control frameworks were actually working or not. So here you see one of the quote by Zuckerberg, and he has actually apologized, and he said that they are now going to invest on what was the large amounts of information that some of these apps and some of these developers accessed prior to the 2014 change, and then see if there was any suspicious activity. Unfortunately, this is too late for Facebook. They suffered significant market capitalization loss as a result, and what they could have done was to just set in this same process then and there itself, and then this could have been maybe avoided. And how AI would have helped, obviously monitoring such a large ecosystem of app developers and checking for what access, what accesses they have and how they were using these accesses is not possible through humans. Even if you were to have an army of people doing that, it would have been impossible to do that in a way that is reliable and consistent. So that's the reason why you need an artificial intelligence system that drives some bit of an automation of that. And more importantly, most scandals happen because of people who are complicit, in those. And this also, unfortunately, and the CMU study corroborates this, that happens at a senior level. So 50% of insiders, who are complicit in some kind of a breach, are managers who are designing these policies and systems in the first place, and who are responsible and accountable for the monitoring and compliance aspects thereof. So that's the truth, and that's why you will need a system that is not solely dependent on humans. For example, some of the things that could have been picked up by AI clearly was to just see the usage of data by all those apps and see those apps that are suddenly starting to use more data. This is exactly what happened with respect to the Cambridge Analytica. Through a Kogan study, they got access of their friends' political affinity for about 50 million users. And this happened just during the election time, and just before the election time. And suddenly the app got access to 50 million users political leaning and political affinity. And so therefore, even if it was not illegal to do that, it would have made sense for Facebook to pick this up as an unusual activity on behalf of both Kogan and Cambridge Analytica, and then put in some kind of an investigation on how this data was going to be used and what was the data that they actually got, and so on. So this could have been done very easily with an artificial intelligence system there. And similarly, more violatingly, was that the information also actually was broken down by ethnicity and race, and then trying to obviously use that as one of the influencing points in the campaign, etc. So this was actually a clear red flag, and this would have actually, again, through an AI system, it would have been fairly easy to see whose data was acquired and what was the profile of the data, and was it disproportionate to a genuine or a legitimate use, and it would have actually given some red flags to Facebook then and there itself. So this Cambridge Analytica. I don't want to go too much into detail, but this clearly explains as to how risk and compliance breaches happen, and how they could have been avoided, and how AI could have helped in that avoidance, through a system of automation and for picking patterns that humans are not good at, or they tend to overlook, and sometimes be complicit with as well. I'll move on, and we'll talk quickly about some of the things that we have done at InnoMinds, and then actually also talk briefly about the AI building blocks. So we did things around cybersecurity, things around regulatory compliance and reporting by way of, say, attestations on things that they comply. We've done solutions that do the personal identifiable information identification, redacting, masking, and obfuscation, so that the personal data is protected. We also have done solutions in insider threat, both based on cyber activity and physical activity, and combining the two, that monitors for employees and sees if there are people who need to be under closer watch, and so on. So we've also done solutions around the risk profiling from both a data perspective and from entity perspective, to see what are the top entities and the top data points that are vulnerable, and that are also need more protection, and so on. We've also done work around the new types of data, the images, the videos, the audios, and ensured that again PII in that is identified and then protected and redacted if necessary, so that those videos and audios and other unstructured data is devoid of any personal data or confidential data. And we've also done work around compliance in terms of ensuring that the both internal as well as to a regulation, that there is adequate monitoring on the compliance, and trying to see if there are any non-compliances that we can foresee or forecast much ahead of time, so that that could be fixed rather than report and breach after it has occurred as well. And we use multiple technologies apart from AI, such as blockchain, for example, to create these distributed ledgers and have data driven through these distributed ledgers in a more secure way, and also ensure that these are non-repudiable, that nobody can deny whatever action they have taken as well. And moving on, we have a process for AI in terms of defining an automation problem in risk and compliance, either in, say, risk assessment or in the compliance aspect, or in any, even in a remedial action, for example, after a breach, and then go through a process of defining the problem, and then and seeking and getting the right data points around the automation, and then building an automation solution comprising of an algorithm, particularly in machine learning and deep learning, and then building the algorithm and then validating on a holdout or a data set that was not used during the training, and then finally obviously deploying it and scaling it. So this is the process that we go through in an AI, and we have done this repeatedly and quite effectively to govern the AI and the automation thereof. We don't intend to actually get 100% automation. In most cases, we are at 40 to 50% automation, and we are augmenting the human oversight and the human intelligence thereof. And that's what we intend to do as well, to not replace but supplement and augment, and also have a governance mechanism, so that we're not depending on one particular individual but a set of individuals. So we also have the building blocks for AI. So the building blocks comprise the data pipelines, including the sourcing of data from multiple sources, both digital as well as offline. And these will include logs, system logs, machine logs, the activity logs, user logs, and of that like, in addition to the user activity data in terms of the transactions that are happening. And these will the building blocks also include the pre-processing and the data prep. We call it data wrangling in the world of AI, to just work with all of that complex data and put it in a structure that you can then apply some algorithm and then automation around that. And then the algorithm itself, and algorithms of anomaly detection, algorithms of finding similar items, or what we call the nearest neighbor problem, are algorithms to cluster and group things into cohesive things, algorithms to extract features from an image or text, for example. So we have all of those algorithms in the AI model to understand to the data and find patterns, and then use those patterns from the point of view of, say, an automation. And there we rely sometimes on the robotic process automations to build some kind of, say, a case management on, for example, like an if this then that kind of a thing, that if you notice this, then this is what we need to do, and so on. So we have the result interpretation relying on human expertise through an RPA, for example, to then apply actions on the insights that generate out of the AI process. So we've done this in multiple industries, in banks and financial services, in commerce, in travel, in telecom, etc. And then this is not risk and compliance. It's not just for financial services industries. It is applicable to everybody, including Facebook, as we just saw. So we have the experience in doing this for multiple industries. From a stack perspective, mostly we've done this through open source, using some of the distributed processing technologies, the big data ecosystem, including the Hadoop and the NoSQLs and other MPP, massively parallel processing databases as well, and use the deep learning in particular, and the ecosystem of TensorFlow, the CNTK, the OpenAI, Torch, and all of these to although we have some preferences to some of these, like TensorFlow for production at least, and then we work with these tools and stacks to deliver these solutions. So at this point, I'd like to stop and quickly move on to some demos that we have. So the context to this, work that we have done is to do surveillance with cameras and do computer vision, and to and do it locally through edge computing. So as you see, what's there in the picture is a person in front of an ATM through a camera that is both fixed as well as which can, rotate, and the camera is sensing stuff around what's happening in the ATMs. You see a picture, of a person with a revolver in hand. So we have deployed solutions, which monitor these ATMs and are looking for any non-compliance to the ATM in terms of people coming in with masks, with helmets on, essentially covering their faces, and also with weapons of threat, including axes, revolvers, rifles, and so on. So we deployed this in India, and in India the ATMs are mostly closed room, and because of the air conditioning reasons, and they need to be actually monitored, both from by regulation point of view, as well as from the banks and their protection point of view. And here is a solution. This is an engineering solution, as you can see, done through deep learning, where we are able to detect the persons in front of these ATMs, and also detect if there are any threats thereof, and then take remedial action. And by porting this on the edge, on the camera itself, the camera has a bit of compute power there, processing, storage, etc. And it's actually a Raspberry Pi based edge device. By porting this on the edge, we are able to do this in real time, not relying on the connectivity to the cloud and the inference on the cloud and the relaying back to the edge of the threat, and then trying to take a remedial action. So this is one of the use cases that we have done, and highlights how unstructured data and data outside the boundaries, both physical as well as the virtual boundaries of an enterprise, can be used from a threat monitoring point of view. Yeah, the second solution is in voice processing. Voice is also a key data, and data that needs to be protected for every enterprise, not necessarily only because every enterprise has a contact or a call center where their customers are calling in, giving in their personal details. Every contact center operation has a set of verification of the identity of the person, and these are questions that are asked, such as, say, a credit card number or a date of birth or an address, etc. These are highly private and confidential data of the individual, and this has to be stored properly and also actually processed properly. So what we have here is a solution that identifies the PII and redacts the audio for that and stores it in a safe way. Ashwant, if you can play the audio quickly and then the redacted audio.
My name is Sumit Das. My phone number is 8017028045. My credit card number is 2213 3427 4512 7422. This is a Visa credit card and the validity of the credit card is March 2007.
Yeah, so that was the original audio. This is a sample audio. So since we didn't want to use any real audio, we asked one of our colleagues to speak this out. So we now are doing the redacting process. As you see here, there are two steps or three steps to the redacting. The first step is to understand what was spoken. So this is speech to text. And then second, to identify the PII involving the NLP. And the third step is to then do the redacting. So you saw here the speech to text output, where the phone number and the credit card numbers are there. You saw that an NLP picked up the sensitive information and the timestamps of where the sensitive information was held. And then the redacting process acted on that timestamps and and then muted that audio. And that, of course, it need not be only muting. It could also be the other things like having a beep sound, so that you're telling that this was redacted, and also scrambling it so that you're not actually changing the audio file, but only allowing people with a key and a private key to unscramble it and listen to the full audio. Go ahead, Ashwin.
My name is Sumit Das. My phone number is 8. Card number is 2213 34. A Visa credit card and the validity of the credit card is March 2007.
That was an example of how the redacting happened, and how you can then store this audio securely. And also, if you are familiar with GDPR, the GDPR puts in a good way of both having the policy and the process controls, and giving the control of a person's data to the person. And if the person has no consent to the doesn't want the data to be stored, it has to be deleted, and deleted from all stores and permanently to so by redacting the PII, then the business is allowing that to be used for other purposes, such as, say, understanding what the issues were, and how the contact center is actually dealing with the customer, and so on. So that's an important need, not only from the point of view of GDPR, but also from the point of view of keeping the risks low of personally identified information and storage of that. uh, the next solution is in the space of unstructured data in the form of text. So what we have is the businesses reporting their 10Q, 10K filings, and these are financial statements that go back to the exchanges and to the regulators. So as you see here is the key financial statement, including a overview and description, and then the tables, the financial statement tables itself, primarily the four tables of P&L, the balance sheet, the equity transactions, and the cash flow. So what we have is a solution that checks whether these 10Q, 10K submissions are proper. They carry all the statements that are necessary, and carry those necessary tables, and ensure that there is compliance to these submissions of 10Q, 10K. As a first step in that, you would need to see what are the key tables that are there in the submission, and also you have to see that all the four tables that have to be submitted are submitted, and that's what we will demo now. So Ashwant will copy now a piece of text without the header. The consolidated balance sheet, as you notice, is not copied, and then he will copy this statement and paste it to an engine that does the natural language processing, and tells what this table is. And then you will then obviously see for completeness of the table, and then tick that the financial statement contains these four tables, and therefore it's a fully valid 10K 10Q submission. So he has inputted this table, a part of it, without the header, into an NLP engine. You will notice some of the stack components there, such as Spark, which is what we used here. We can use this, we can do this with other stacks as well. This is on the back of Hadoop, and once this completes, you will then get the key classification of what the table was and whether it was a balance sheet. As you see, it was assets, and the predicted class was a balance sheet. We didn't put in the header. We just looked at the items in the statement and then predicted that this is a balance sheet. It's not a trivial problem, and it took considerable time for us. In the interest of time, since we have only about 10 minutes, I'd like to stop here and see if there are questions. And You can actually send the questions in writing, uh, and we would be answering those questions.
Yeah, Ravi, there is one question on what are our accelerators and the different models that we bring to the table, and do we have any approaches to determine such regulatory mechanism to automate using AI?
Yes, a good question. So we do have an accelerator by name iFusion. We call this as the AI in a box for the life cycle of AI. So as mentioned, AI is not just the algorithm. It's not just about a CNN or an RNN with a 4-gate LSTM, or a dense neural network. An AI is more than the algorithm. It is right from the data acquisition and the pre-processing thereof to the setup of the algorithm itself, and the setup itself requires some level of sophistication in terms of the ports, the runs, and the fully connected versus otherwise. So what we have in iFusion is something that supports the life cycle of AI, and it is on scalable stacks. It's scalable everywhere. This platform that we call iFusion, and it can be used to process terabytes of data. And from an engagement point of view, we take an abstract problem of automation, and then do the conversion of that abstract problem of automation to an AI problem, and in particular an automation problem, and then go about uh, acquiring the data and doing the data workflow, and then the algorithm and the validation to then deploy it into production. So that's how we engage, basically end to end, and in various models, including some consulting to begin with, and then the implementation, and then also the production support thereafter.
Yeah, Ravi, the question is if we have to identify such a automation, this one, typically what is the time frame it might take for an industry if we start from means a consulting phase if that is required?
Yeah, so one of the things that we bring through the acceleration is basically the time reduction, and what we believe is that through our accelerator and our experience, we can actually get to a use case development with automation in roughly one half of the time that it takes otherwise. And we have done many AI projects where we are able to complete the use case in about 12 weeks, in 3 months time frame. It would have otherwise taken 6 months to do that. For example, all of the ones that you've seen, including the audio redacting, the monitoring through the cameras and the surveillance aspects, or The text processing 10K submissions have all been completed in less than 3 months, mainly because of the accelerators that we bring to the table.
Yeah. So the question is, our approach, is it vertical agnostic, or it can be applied to any industry or any industry segment?
Mm, Yeah, again, good question. So the approach and the building blocks in particular are pretty horizontalized, but we do have data models and semantic data models and algorithms that are fine tuned for a specific industry. We are we have the expertise in the verticals of banking and financial services, in telecommunications, and in commerce, and these are the verticalized point solutions that we have. But as a platform, the accelerator that we have is pretty much agnostic to a vertical, and can handle a problem in a wide variety of scenarios and verticals.
Yeah, Ravi, another question is on the technology stack. So if we are supposed to build a solution using AI solution, what is the typical technology stack?
Yes. So the typical technology stack, in the life cycle of AI, starting with data acquisitions, etc., would be to use some of the distributed processing data pipelines such as Spark, or Presto, or Scoop and Flume and Kafka, etc., both for training and for production, and do a bit of pre-processing, etc. So, for example, if it involves some transcoding and something like an FFmpeg to transcode the file format from one to another as required for an algorithm, like for example, TensorFlow uh, expects the images to be a certain format, like a JPEG, etc. So that all of that will be on the back of a distributed processing through Spark. For example, we achieve transcoding and FFmpeg in a distributed way with Spark as the executor or the coordinator. Uh, and the FFmpeg itself can be anything, could be a C binary or a Python binary on distributed nodes as well. And that's the pre-processing. So essentially distributed processing and Hadoop and Spark in particular. And the algorithms itself on the deep learning front could be some out of box, like what our iFusion has, or it could be just out open source, such as a TensorFlow, which is what we prefer for production. And also while experimenting with a CNTK or a Keras, etc. as well. Yeah, as a
Yeah.
next step, I think what we offer is a to the people who have attended and people who have registered, what we are offering is to discuss a use case or discuss an automation that is there in your mind, and you're thinking of achieving it through artificial intelligence. So we are offering that we will do a workshop for just that use case, a workshop that goes through the business problem, and then translates it into an AI problem, and then identifying the data sources for that and so on. So we have done this in the past. These are neatly capsuled workshops, bringing the right stakeholders and achieving meaningful outcomes, not just in terms of, say, documentation, but in terms of some decisions, and including, say, stack choices and technology choices, etc. And what we are planning as a next step is that if some of you are interested to conduct these workshops in a time boxed fashion, we would love to do those workshops and get to some key decisions on how those business problems will be targeted for automation, and what kind of tools and stacks we will use, and what data sources we will do. And post that, we can then get engaged in a full scale implementation. And often, even in the full scale implementation, we start with what we call an MVP, a minimum viable product to first get to a product that can be used, even if it doesn't have all the scenarios covered, and then to go and then scale that to a fuller implementation thereafter. So that's the process we go, and that's what we want to offer to the people who have come here and people who have registered. All right. So thanks everybody. Have a good day or evening or the rest of the night, based on your time zones, and we sincerely appreciate for the time that you have given to us. Thanks a lot.